All right, good morning, guys. So I did want to get back into the classroom and kind of show y'all a few of these different organisms and kind of talk a little bit about the symmetry and the anatomical features that we discussed in the video with the notes before you got to this point. So a few things when we're talking about symmetry, notice that we kind of said that there were three different types. So there's asymmetry, meaning that there's no symmetrical components to it at all. You can't divide it out into equal components without the entire organism. And then there's radial symmetry, divided from that central axis. And then there's bilateral symmetry, like a human, so you can divide it in half on each side, an eye on each side, an arm on each side, so on and so forth. So the first thing we're gonna start kind of looking at, and if we were in class, you would have the ability to kind of touch these things and move them around, but asymmetrical organisms would be things like a sea sponge. And I told you in the video, I said, don't think of SpongeBob, because SpongeBob is actually like a car sponge, but think more of an actual sea sponge. So this is a natural sea sponge, and this is exactly what they look like. It kind of looks similar to, they actually do on SpongeBob make his parents sea sponges. So they are actually real, but this is what a sea sponge looks like. They come in a couple different forms. So notice this one has pores all over the side. So does this one. This is a type of sponge called a tube sponge, and he's gotten a little squished over the years. But different types of tube sponges, and basically what will happen is they'll kind of grow out of coral reefs looking a little bit like this. Here's actually one that was attached to a coral reef. So you can kind of see what I'm talking about when I say that something is asymmetrical, meaning that it's like a sea sponge where you cannot divide it symmetrically at all. So it would look similar to this, and that doesn't look symmetrical at all. So think about in elementary school when you had to divide shapes right down the middle. Asymmetry, no symmetry at all, all right? We have organisms like starfish and sand dollars that have radial symmetry. So starfish has what is referred to as pentaradial symmetry. And pentaradial, think of the pentagon, so 5-part symmetry, divided out from that central axis. So we can divide the starfish out here, 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 and here. All right, and we can kind of divide it out actually from its central axis being its mouth, which is kind of cool. And that does apply to all of our different starfishes. So they may have more than just 5 legs, but they all have that pentaradial symmetry. Another organism would be something like a sand dollar. And usually the sand dollars you see have been bleached out. They're real pretty, perfect. But this is a sand dollar, and sand's actually falling out of them as I touch them. But a sand dollar does have that same radial symmetry. So we can divide it from that central axis out into our equal components. Another organism that I talked about, I'm gonna try to find it down here, was a sea anemone. And a sea anemone, here's one for you, is what Nemo lives in. That's its petal disc. This is what attaches it to the coral reef or whatever substrate it's attached to. But a sea anemone is also an example of radial symmetry. So if you look straight down at something and it looks circular, that means that it has that radial symmetry to it. Another example is a jellyfish. I'm trying to think, here's one. All right, so same type of thing. Can you see that little guy? It's kind of blurry. If you were looking down straight at the top of a jellyfish, it's gonna have that same radial symmetry, so dividing from that central axis out. And then the last type would be bilateral symmetry. I'll just use my little pufferfish guy because he's the first one I have over here. But our pufferfish is a prime example of a bilaterally symmetrical organism. So as we start getting more and more complex, our symmetry starts going from asymmetry to radial to bilateral. So our most complex organisms are gonna have that bilateral symmetry to them. You can divide them straight down the middle. Notice he's got an eye on each side, his mouth is divided in half, he's got a pectoral fin on each side, and then his tail can be divided down straight down the middle as well. So he's got that perfect bilateral symmetry.